is the 1. Um, so what do you think here? Do you remember how to round that? Sorry, arrow's almost up. 15.8 to the, if we were looking at the tens place, does that 5 cause the 1 to round up or down?
Up.
Round up to 20. Okay. So now what you should be thinking about is, well, 25%, if that's something you know, yeah, that's a quarter. 25% is a quarter. Which of these numbers can you take a quarter of?
Uh, 20.
Both. Oh, actually both. Yeah, 16 and 20. Now, 16 is a better estimate because you can get exactly a quarter of it and it's closer to 15.8. So what would be 1/4 of 16? Because that's what this is really saying. It's really saying 1/4 of 16.
Um,
I know it's probably early in the day for some math, but a quarter is just dividing a number by 2 twice.
yeah. What would it be 4?
Yes. Yes, it is 4. So the answer here is 4. So what we're doing, like there's a lot written on the screen here, and a lot of it isn't really necessary. You're trying to get a number that basically everyone would agree with without saying why they agree with it. We don't have to say, well, it's the ones place, it's 16, and this is a quarter. You're getting to this. Um, it's like the bill is $15.80 for the 4 friends. What are you guys going to pay? We're going to pay $4 each, and that's okay. All right. Well, so like as usual in your, I would love to give you more like that one, but they sort of transition to a different type of problem here for the next one. 9% of 38. So nine's kind of a bad number, and so is 38. Like 9 doesn't go into 38. 38's not really nice. 9% isn't really nice. What would you say 9% is near? What's a what's a nearby number
Um,
that could be considered nice? So I'm looking for 10%. Why do you think 10% is a nice number?
um, because it's the next number up.
Okay, but but let's just say it was 17. The next number up is 18. 18 isn't nice. What properties of 10 do you remember from, other courses or other manipulations with the number 10? What do you remember about 10?
Um,
Feel like I'm speaking, Spanish to you right now.
yeah,
Um,
we
okay.
didn't talk about that.
Well, yeah, but this is just things that you would do in real life, that you might like, and I see, unfortunately, I don't want to just give you the answer, but like, what is 45 times 10? Let's throw that out
Um,
there.
well, 450.
450.
450.
Why could you do that so quickly?
Because I know in my head that like um I don't know.
Okay, well, the traditional thing that you have learned in school is that you take the number and you append a 0 at the end.
Yeah.
And maybe I'm just putting into words what you already know. What is 36 times 10?
360.
360. What is I don't know, 543 times 10?
Um, sorry, um, 5,403 or 30.
Yeah, and you can just give me the digits. You don't have to necessarily say it correctly. We're not worried about emphasizing that. So each time you're just putting a zero at the end. So what about, I don't know, like 600 divided by 10? What does that become?
60.
60. How were you able to do that so quickly?
Um, because uh
So what I'm really asking is how did you go from this number on the left, 600, to this number on the right? Like, what do you see that's the same or different?
I just will um um
This isn't meant to be complicated. Like I'm literally telling you like, hey, there's two numbers on the screen. What's the same and what's different about them? Like, what do you see that's the same? What's different?
um oh 1 0 is subtracted.
Yeah, you got rid of 1 0. That one's gone. Like this is not like that, and that's why I guess I'm a little bit perplexed here because I if you're in this class, you at some point learn how to multiply by 10 and divide by 10. And it's like, oh wow, this is really cool. Like you can do it pretty quickly. You can take any number and multiply it by 10 by just putting a zero on the end. Oh, that's cool. You can divide by 10 by removing a zero. Now there's some other things that could be in there, but like that's why 10% is a nice number. So if we go back to our problem, the one that we're looking at, 9% is not a nice number, but 10% is, well, because it's easy. It's easy relative to other things to multiply or divide by 10. Okay. Now, a percentage, we talked about this last time. What is 10% as a decimal? Do you remember that from last week?
Yeah.
Can you tell me the decimal of 10%, please?
Yeah. 0.1.
It is 0.1. Okay. We also, I think, talked a little bit about this idea of you're moving the decimal. So if you're taking 10% of 38, the decimal on 38 is there. You're moving it left one. Did we talk about that?
Yeah.
Okay. I don't know if we did or not. That's because sometimes I explain it differently depending on who I'm working with and the class you're in. So the answer is 3.8. Now, is this a nice number?
Um
Sometimes maybe think of it as friendly. Heard that before. I like that a lot.
yes,
Okay. Why is that a friendly number?
because it's not the same, but it's similar to 38.
Okay. If you can't tell, what I'm trying to get you is to really like engage with this material where you give me your opinion. Like I don't know if like 3.8 I guess could be friendly, but I mean like give me a context where you would use 3.8. Like what's a scenario where this number would be meaningful to someone? So
I'm
I'm gonna take your silence as it's a tough one. Like it's like, well, I don't know because it's a weird number. It actually is. So the only thing that really comes to mind for me would be like GPA, maybe if you're weighing something. Okay. Now, what is it near? Well, it's near four. Is four a friendly number? I would agree. I would think it would be friendly. You can think of four as being like um, a number that we might use regularly, or if you tell someone, hey, grab me four items off the shelf, that's pretty clear. But you say, hey, weigh me 3.8 bananas, that's going to be a little bit awkward So sometimes the answer has to be meaningful as well. So again, we're really spending a lot of time on this problem, but what can happen is like if you manipulate one number, if you're like, okay, 10%, then this number, maybe that's 40 is a better number to do it with. Because like we talked about, 40 divided by 10 is 4. You just drop one of the zeros. That's easy to do. And that's how they want you to do this problem. They want you to sometimes manipulate both of these because they really want your answer to be nice in the end or meaningful, depending on the context here. Any
Yeah.
thoughts on that?
No.
So the question is like, how much do you manipulate the numbers? And the answer is, well, it depends. And that's a tough answer for most students because it's like, but really your teacher maybe wants you to be able to explain. And that's what I keep trying to get you to do here is to explain like, why did you manipulate the number to what you did? Okay.
Mhm.
All right. So let's start with 1.2%. Is that a friendly percentage? Is that something you would expect to use a lot in your life?
Uh, yeah.
Okay, why is that?
No.
I mean, another way I could ask it is tell me the last time you used 1.2%. And unless you're in a weird situation, I don't know when you would use that. And but you just said, "Hey, yeah, that looks okay to me." But no, it's not. No, this is not. This is weird. It's an odd number. Odd means irregular or weird or strange or you get into situations you're like, God, it just doesn't feel right. Like this doesn't feel right. 1.2% is not a friendly number to work with. Okay. And you might be wondering, well, what is a friendly number? Well, that's where this gets challenging, but is 1% better than 1.2%? Yeah,
Yeah.
yeah, it is. It's easier to manipulate. All right. What is 1% as a decimal?
Um, uh, 0, 0.1.
Didn't we just do 10% as a decimal as 0.1?
Oh, yeah.
So they can't be the same. So is this one wrong or is there something else to do with 1%? And if you don't remember the rule, you're dividing by 100 to go from percentage to a decimal.
So 0.01.
0.01. Good. Okay. And that's not great. I mean, it's better than adding a little two over here. That's not really it. But okay. Now, relative to 1.2%, is 1% did the number go up or did it go down?
Uh, Down.
It went down. Yeah. Okay. So we should also go down on this number. And the question is how much? And that's what's up for debate. It's like, I don't know how much to tell you. Um, it could be that you go down too far or not far enough. That's what's really tough to decide. So again, like what is a nice number? Nice numbers typically end in 0 or 5. So what is a number that ends in 0 or 5 that's near 127?
Um, Wait, what was the question again?
Okay, are you able to see my screen?
Yeah.
Okay, are you able to hear me clearly?
Yeah.
Okay, if you can't, please tell me, because I do believe that I'm not asking anything really sophisticated. I'm asking about this number right here, 127. Can you think of a number that's near to this number that ends in 0 or 5? And if
One
anything I've said
point
is unclear, sorry, go ahead.
1.30.
Okay, so how about 130? That's reasonable. Okay, that ends in a zero. Now it's not a decimal because this is a whole number, an integer number. What if you wanted to go smaller because we said we need to go down?
Mm, 120.
120. Okay, so that's good. Now, I like 120 because 1% of 120, so we're changing our problem to 1% of 120. 1% means to move the decimal left two places. So here's the decimal. If you move it left two places, what is the new number it becomes?
1.20.
1.20 or 1.20, and that's okay. That's totally okay. Now, me being, the person that does math all the time, 125 is probably the better number. Like it's probably the one that like kind of is like the best one, all things considered. But this one is really, really good too. Like it's reasonable. And reasonable means okay, we're kind of all okay about how it is. Okay, let's keep going here. Um, a lot of this is kind of up for discussion. It's like, well, do you do you have a reason for like why you're choosing this number? And, and I think it's okay. All right. So 0.53% of six out of these two numbers, which is the one that's sort of the odd one in your opinion, and why?
0.53
Okay, why is that one odd?
because um it doesn't end in a 0 or 5.
That's true. Okay, so to make this into something that's reasonable, we might go to 0.5%. Are we going up or down?
Down.
Down, yeah. So um, sometimes you go, you manipulate both numbers down or one up and one down. It just depends on the situation here. But what if it just said 0.5% of six? Okay, that's that's better than the original one. Now, it's like there's all of these are a little different. It's like, well, should you manipulate six? And I'm not sure. I'm not sure you should because um, it's it's not great, but it's doable. Like it's just a single number. And then sometimes you literally just come off to the right here and you multiply. But you have to convert to a decimal. So that's where it gets a little bit like, this is 0.005, 0.005 times six. All right, which ends up being 0.030, which, I mean, it's not super meaningful, but that is what it is. So,
Mhm.
but so far, I think your main takeaway is what you just said. You're like, hey, it's got to end in a zero or a five. All right, so new problem here. I like this one. This one's a little bit better than some of the others. Um, what is 200? What is the zero or five number near 202? A number that ends in zero or five.
Uh, neither. Wait.
Is there a number near 200 that ends 202 that ends in zero or five?
Oh, 200.
Yeah, I actually said it twice. And you said neither. I'm not, maybe you thought I was asking something else here. We want to find, a number near. Now you could go 205, but that's not as nice as 200. 200's got a lot of nice properties. It's got two zeros, it's multiple of 100. 6%. Ooh, that's not great. But what is a number near it? Like what if you could only change this digit? What would you go to make it nicer?
0.5. I mean 0.05.
Yeah, 0.05. Okay, percent. So this time Then you got to convert the percent to decimal, so it's 0.0005 times 200. Will you multiply that out for us, please?
Yeah. Zero 0.1.
All right, and that works out nice. All right. So like the more traditional problems, I mean, I wanted to get through the ones that you guys had there, but the more traditional problems would be like 21% of, 397. All right. And the idea is typically that if one goes down, like 20%, the other one needs to go up. You typically want these to balance out. You typically don't want them to both go in the same direction in general. Like there's always exceptions, but the new problem should be substantially easier. So much easier that you can do it without a calculator, right? Now maybe you can't or you're not sure, but this is substantially easier than the previous one. So the estimate here ends up being 80. If you have a calculator and you could do the exact one like this, the true answer is 83.37. And there's scenarios where, this is bad and this you really need the exact one, but it just depends on the problem. All right. Typically it's like they'd say, okay, 19.7% of 62. It's like, well, that's about 20% of, 60. And you say, okay, that's 12. And then if you go to the calculator for the actual true answer that is perfect, and you get 12.214. I mean, hey, that's close enough. That's the whole point of this. Now, on your standardized tests, the last comment I'll give you is that like the answer choice for something like this would be something like, let's just say the correct answer is 12. It might be like 8, 10, 12, and 14. So if you can estimate reasonably, you get the answer without having to do the calculation like that. All right. It goes quick.